first is the problem identification. So in the fall 2009, we gave a set of questions to the cell biology TAs and to ask them to identify controls. And we find about 57% of TAs have trouble identifying positive control in an experimental setting. And they either indicate the positive control are experiment itself, or they are negative control, or they are unnecessary. Remember the 4 groups I explained. So they are really having trouble. And 40% of TAs fail to identify a negative control in another experimental scenario. So you can see roughly about half and half. About half of the TAs having trouble either with positive control, with negative control, or both. So the same problem is observed also in the student population. So most sophomore or junior students in MCDB majors fail to recognize the role of experimental controls. Those students are already taking all 3 MCDB labs, plus all the intro lecture series. So I will talk to you more specifically on their.
Could you say a little bit more about how you recognized that this was a problem for students? Like, was this just an observation of labs or observations of classes, or?
This is a specific test I'm going to talk to you about, the questions that we developed. Okay. So here is the students participated in this study. So I guess I will get back to your question in the next couple slides. So if you look at the 2 boxes, you can see these students in the fall of 2009, about 101 students, they have gone through the intro genetics and cell biology courses, or some of them already taken the 4th lecture, which is the molecular biology. So these students took at least 3 lecture series plus 3 labs associated with these courses. Okay, so there are no labs after the cell biology lab. So that's it, whatever the lab experience they get. So this group, guess what, serves as a negative control, right? If you think about it, we don't expect them to do differently, as the one that haven't taken the invented cell lab. So this is a control or negative control for our study. Looking at the right-hand side, these students are the experimental group because they are taking the spring cell biology lab, which we incorporate a lot of control activities into. Are you clear with the participants for this study? Okay, so you may wonder, what have we done in the course to make a difference, if any? So this is the invention I'm going to talk to you about. So the control activity that we implemented in the spring cell lab are the following. So we have roughly about 8 control activities or tutorial we gave to students during the spring semester. So 6 of these activities are 1-page long experimental scenario, just like the one I gave it to you. And then we mostly ask the students to identify what are the positive controls in this experiment, what's the purpose of these positive controls, what are negative control, if any, explain the purpose of that control. Another type of activity, which we only gave once, which is much more challenge. Some people would argue, well, you should give all these type of activity to ask students to think. But I was a little hesitant because I think students have so much trouble just to identify. We should probably give them more practice, and then eventually leading them to be able to design their experiment and including the controls. So I call this reverse control activity or backward control activity. Basically, it's on your 2nd page, flip over. So basically, instead of giving them the experiments and ask them to identify the controls, we simply tell them this is the experiment results we find. And in order to get these results, how do you design this experiment, including the controls? So it's kind of the reverse way. And this is also interesting. If the results are unexpected, you didn't get what you wanted, what could go wrong, right? So one of the possibilities, of course, you don't have all the appropriate controls. So that's what we try to emphasize. And students make a lot of discussion and kind of walk through painfully on this activity, but I think it's good for them. Sometimes no pain, no gain, right? So we have one activity, which is we gave students, it's outside of the classroom. Oh, I have to say the first two are inside class activities. Students first answer the question on their own, and then they discuss as a group of 3 or 4. And then they revise their answer, after their discussion with their peers. And they spend roughly 20 minutes per activity. So that's kind of for this one, it's an online tutorial Mike and I put together. It's on this website. Students spend time at home and go through the activity and answer questions on that. I heard students also think this tutorial activity is difficult. We gave that kind of as the last activity. So total 8 activity, pretty much every week they practice on this topic. So getting back to designing the pre and post assessment. So I got some questions from the MCDB researcher and asked them to provide me some good examples on their experiments, interesting, experiment example. Then I write up the questions in the multiple choice format with short essay questions. And then I revise the question, finalize question by feedback from different people. And then have a pilot version, which we gave to the TAs. Remember, get back to your question. The TA actually took this long version, pilot version, and that's how we found out there are difficulties. And then the short version, significantly short, which only has 2 sets of questions. It took students about 15 minutes to complete. Unlike this one, it took TA 2.5 hours to do. It's really too long. But it did reveal a lot of their difficulties and misconceptions, though. So these only took 15 minutes, much shorter. And we don't have to go through all of it. That's actually the questions. So the first one is kind of easy questions or more applied questions. If you want to test a new drug for treating Alzheimer's disease. And here are the 2 groups. So you have, or 4 groups if you want to say. These 200 people are giving a drug, symptom improve, and 75 giving the drug, the symptom didn't improve. And 50 were giving placebo, symptom improved. 15 were giving placebo, and the symptom did not improve. And then we asked the student, is there a negative control in this study? What does it control for? Is there a positive control? What does it control for? And then we asked them if this drug was effective. So you can think about it if you would say A or B for the effectiveness of this new drug. I'll give you just a few seconds to think about. And what does it involve? What are you thinking? Okay. So I will tell you what students think. Okay.